Okay, today I'm going to discuss with you on chapter number 9, especially on the panel data analysis. First of all, I'm going to mention to you or discuss with the idea behind of panel data analysis. This is going to be the final chapter, as I already mentioned earlier in our class, and certainly that although it's a final chapter, this is not going to be the end of econometrics or the modeling of economics, because this is certainly one another part of the idea. So we're finished up the time series, especially. We're focusing on the time series starting from unit root co-integration, and then we go for the VAR or the VECM estimation. We go for the dynamic analysis. Now we move forward into another new topic, which is panel analysis. All right, so recap of what you have done last semester. You do on the OLS estimation. So now, same thing here, the panel analysis that involve actually two sides of the coin. One is called panel regression, which mostly involve of what they call as the panel regression analysis, right? The panel regression analysis or the pool OLS, right? This is the idea behind first before we started off. The pool OLS is the first model that we're going to discuss, and then after that, the random effect and the fixed effect model. So the RE and the FE model under the panel regression family school of thoughts. And then after that, the other side of the family school of thoughts is what I'm going to discuss with you. Also, not in this part of the video, is going to be what they call as a NPT, which is non-stationary panel time series, which is very much related to what we have just finish most part of this class, which is the time series analysis. But now we move forward into the different dimension, which is panel kind of a data analysis, right? So that is for the start. All right, so economists often study time series, certainly, right? Economic studies now mostly applicable time series, but lately or the past numbers of years, panel data have becoming more prominent, becoming more famous, becoming more applicable, especially in the economics studies, in financial studies, and so on. So there's a perception, especially for certain researcher. Actually, there's a perception in that certain researcher. I would explain to you what the perception is, especially in our faculty, the Faculty of Economics and Business. The management marketing side, normally we would say that they use the primary data, right? The primary data. This is the common understanding. The economists or the economic studies normally use time series data, while the finance studies normally will explore panel analysis. Yet, in a way, that is true, but I do not agree with that kind of justification, or the kind of economics must use time series, finance must use panel, and the management marketing studies normally involved in the primary data or the questionnaire. Not necessary. It can jumble up all sort of thing. The economists also use panel analysis. The finance also use time series when it's available. They especially dealing with volatility, stock market estimation, and so on. They deal a lot in the time series, high frequency data. That will be true. And the marketing management side, yes, they explore a lot in the questionnaire, but they also, they have the data available. Surely they're going to explore the time series and the panel data also, or they explore more of what they call as longitudinal kind of estimation, which is a kind of like a panel in a way, but not directly related to panel. Anyhow, I'll just give you kind of understanding of what is happening. So there's no kind of indication says that if you study economics, you must do time series. No. All right. So this is what normally happen, right? This is what we are doing, but not necessarily true. So one of the common problem actually for estimation time series is sometimes it's very low observation, as you already realize. Some of you might get less than 20 years of data. and then it might affect the whole estimation. So one way to solve the thing is to use panel data or to pull the data. So time series analysis also confronted with the risk of automatic bias result because it failed to control for individual heterogeneity in the data. So this is still go back to the classical linear regression model, where heterogeneous are still there, or we assume individual heterogeneous is still there. So here we could not really address that issue because time series analysis mostly concern about autocorrelation, right? So anyhow, also there's an issue of multicollinearity. So one way to solve has been suggested here is solution is to have a pool data into the panel of time series from different cross-sectional unit. So we call it panel. This pooling is referred to panel data, and there's a 2 dimension here. So normally we do estimation for 1 dimension. Either we use cross-sectional, which is called N, or time series, which is called T. Here in this case, in the panel data analysis, we have 2. So the total sample will be N times T, right? N times T. So it increases the sample size, right, with the cross-sectional elements and the time series element into the panel data analysis. So it can goes into household, firms, individuals, country, and so on and so on, pool over time, right, over the space as well as time. So this is what panel. So in other words, actually panel data pool together and it have much more rich information is that. So while I refer to this book by Professor Lau Seong Hock from UPM, a book called Applied Panel Data Analysis, I'll show you the book at least maybe in the class later when we deal with this. All right. So the advantage, right? The advantage of the benefit of using panel time series. So panel data actually it can control for individual heterogeneity. I already explained to you what is heterogeneity, which is very much related. Go back to your econometric class, especially when talk about classical linear regression. We assume that in classical linear regression we assume that the variance are actually constant over time, which is homogeneous. But here, individually, it should be. We acknowledge that each individual are unique in a way. So that's why it's heterogeneous. We are similar but not the same. So it's heterogeneity, control for heterogeneity because of the issue of cross-section. Cross-section is individual mostly, and time series is mostly refers to a period of time, right? So this is one of the benefit. The second one is more information on the data set, means that you can get a bigger sample size, which is better comparatively to either you just do the time series or just a cross section, and more information as I already mentioned to you just now. Better to study the dynamic of adjustment process accordingly to the book of Prof. Lau Seong Hock. Is mentioned also. You can see the dynamic adjustment. You can see what is happening within the group of countries, maybe within the group of companies, of firms, and so on and so on. Right. So it's interesting to look at the different dimension and perspective. And the fourth benefit is that it can identify the parameters that would not be able to be identified in the pure time series and pure cross section, because cross section only 1 dimension, time series only 1 dimension. When we marry them together, it become panel. Then certainly you have a more richer information, right? Surely then you get more better estimates and more better recommendation related to that. Especially we want to know, sometimes we want to know whether a certain impact towards a certain group of countries, or maybe across the sectors and so on, like what we have right now, the pandemic itself. You can see the impact maybe of the pandemic towards the different sector over time, over the time series, or over the we have enough time series and the cross section to do the panel analysis, surely, right? So the panel analysis also very important, especially very useful for to see firms level or company data set. Means that we can go into the micro level or even into individual. Yes, you can do that actually. So it's an interesting to see the firms in the sector, in particular sector, or all the other sectors, or the sub sector. We can focus on that, and this enable us to estimate, to know the idea, to look into much more micro unit level, right? So and then as I told you, if all the data is there, means that all the data is there, we call it balanced panel. And it's unbalanced panel means that certain years or certain cross section is missing or is not available. Is okay, no problem, we can do both of the estimation. The missing variable is acceptable in this sense, right? So is I mean, I already explained this one indirectly. More informative, more variability, less collinearity, more degree of freedom, more efficient, right? Y panel data. Here the micro panel, as I told you just now, gathered on individual firms and household. This is called micro panel. The macro panel looks into a bigger on the bigger platform, which is the macro, have the longer time series, unlike the problem and so on and so on. So the micro panel look into much more of the bigger cross section, and while the macro panel look into much more the bigger time series. All right. So for example, the difference is that if you see here, if you see this equation I and T, I normally refers to cross section, T normally refers to time series. So if you combine both, it's called panel, right? So here total observation is, as I already mentioned to you. So here we considered that as a balanced panel. All right, so this is in a matrix form where you have the cross section dimension and the time series dimension in both way. So that's why it's a marriage, it's a integration between cross section and time series data, right? So since panel data embodied information of both cross section and time series variation, we can decompose the variance, the variable variance, into two components. One is individual, one is time mean. For period T, individual mean for, so because we have two different information, and that's why we need a different types of modeling structure, especially in panel regression. Now you are moving into panel regression, right? This one also the idea behind the theory behind of a panel regression analysis. Then the overall variance can be decomposed also, right? Here the same thing, the variance, individual variance, or the variable variance can be decomposed into individual mean and time mean, and the overall variance can be decomposed into within variance and between variance, right? So the overall variance is, yeah, this is what we do in the classical linear regression. So here now we can differentiate between whether that variance is within variance or between variance. Within the context of panel, we have two kinds of variation. So it's between the cross section, within the cross section, or obviously both or none in that sense. So within and between. Within the variance capture how much of the overall variance is due to variability within the economic unit, the time series variation. So this is within variance. Between will be we see the variability across the cross section, the unit of the observation, which is the cross section. So say between and within, because we have two dimensions here. Remember, we have two dimensions here, right? Yes, this is the idea behind. Again, at least we have in panel regression, you have three types of modeling, or three types of model that you're going to use. One which we call like this. The first one we call pool OLS or POLS, normally refers to P or OLS. It still use the concept of OLS here. The only different now, the data set are in panel and additional of some understanding or some assumption behind. All right. So, yeah. So this is one model POLS. I'll show you the equation later. Show you some example also in the second part of the video, especially using E-views, how we're going to estimate. And then the second one allowed for fixed effect. The third model is allowed for random effect, right? So to choose the best model, like how we do it in the econometrics, to choose the best model, this method will be used, the Bruce-Pagan LM test and the Hausman test, to distinguish between the BP, or the Bruce-Pagan LM test is to distinguish between pool and random effect, and the Hausman test is to distinguish between random effect and fixed effect. We'll show you when we up to these slides. All right, so for example, like this is an example. Suppose Y is crime, X is employment. We have I from 1 to n states for the cross section, and T is the time period. We specify the model as like this, IT day. Here is X is unemployment. Here is crime. So how unemployment affect crime, right? How unemployment affect crime in that sense. So the assumption here, how we develop the structure of the model, is how we develop as if we develop in such a way. So this is the common example of panel analysis. All right. To accommodate the heterogeneity in the panel, the error term is decomposed into two independent components of the composite. Error term of one is called individual specific effect and is time invariance, hence it's not necessary to use the time index. And the other one is where this is where we have this fixed effect and random effect come into picture, the model of the fixed effect and random effect. So here the assumption of the three model here, of the three model which we're going to estimate in the second part of this video, is that the panel OLS assume no difference among the data metrics of the cross-section dimension. Means that it's common constant over the cross-section. All right, there's no difference between estimated cross-section useful under hypothesis where it's homogeneous, right? We assume that you're using this sample, for example, a sample of high-income country, or maybe the same stage of development of countries. Like for example, if you use ASEAN country, this model might not be suitable, because ASEAN development, the 10 ASEAN countries have different types of development, so it's not really homogeneous because it's heterogeneous in that sense. All right. So this one pool OLS can so the data can be pooled. We pool the data and then we estimate the data using OLS. That's the meaning behind. All right. So however, the pool regression certainly will be resulted in heterogeneity bias, because we do not consider the individual change. We assume that they are constant over the cross section. All right, so this is just an estimate. Go back to the same econometric idea behind of the regression analysis. Same thing here. It's just a regression. The difference is that the data structure here, is in panel. All right. So this one is the pool model. Again, intercept and slope are the same across the unit and time, but assumption may be restrictive because you assume it's the same. So in addition, the endogeneity can arise in social science because of three reasons behind the endogeneity. Can test for endogeneity also because of omitted variable, because of measurement error, because of simultaneity. Is partly of that is correlated. So that's why we need to address this issue also, especially in panel analysis, panel regression. All right. So this is for pool OLS. Now we move forward into the second model inside the panel regression phase, is called fixed effect. All right. The fixed effect. The assumption is that assumption 2 and 3 allow the intercept to vary across the states, or allow the intercept to vary across both states and time. It refers to fixed effect. Means that there are changes. We allow changes, so it's called fixed effect, right? Allowing each states, let's say the data are in states, right? In this example, so or if it's in firms, there's a different intercept for all the firms accordingly in your cross section. So it's called fixed effect in that sense. All right. So here here we use the kind of a dummy variable kind of estimation that EViews will do it for us, and to estimate and come up with the necessary result. All right. uh, this form of estimation normally are also called as least square dummy variable. Right. So but the idea is that again, this one is very much important. Yeah. A further extension is allowed to intercept variance across the different time period. At the assumption number 3, this is called two-way fixed effect. Normally, we just assume one-way fixed effect, means that allowing the cross-section dimension constant to change, right? To change within that cross-section, or within that the panel data itself. All right. So this one is important to allow the regression function to shift over time to capture the changes in technology, government regulation, tax policy, external influence, and so on and so on. This one is more towards the two-way fixed effect, right? The two-way fixed effect. This is just an extension, but normally we just do one-way fixed effect, which is the fixed effect model. The common fixed effect model. But here is also can see that through time, it allowed the change, allowed the changes. What changes have been made, right? So like for example, right now, for years to come after this, the impact of the pandemic will be very much important and very much disrupt the whole economy and the policy cycle, and we can see that, we can examine that through this simple analysis from the panel regression using the two-way fixed effect, for example here. Then we move forward into another model called random effect. So random. The fixed effect assume each group firms have non-stochastic group specific component of Y, including dummy variable controlling the way of Y. But this unobserved effect can be stochastic in the way, right? So it can be random. So I assume that we assume that yes, just now we assume that fixed effect, but the effect is fixed, although if the variation can have to change. But here the unobserved effect can be stochastic. That's why it's called random effect. All right. So here that our unobserved component, which is represented by this, is treated as the component of the random error, and the elements of error which varies between the group, but not within the group, is the element of the error which varies over group and time. All right. So this happens, and when we talk about just now, between group and within groups. Here we go back here, between and within group, because we can decompose that into two different dimensions here. Yeah, within group is to capture the variability between the economics unit, the time series, and the between one is to capture the cross section variation. All right. So in that sense, so both model actually do capture between and within, but here we capture the elements of the error which varies between group but not within group. So it's between groups, so between the variation of the here between the variation between the cross section dimension. Again, it can be random in that sense. All right. So this is the assumption make. So we could introduce the error component which varies across the time period but not across the time. With this, again, this is called two-way, but one-way random effect is what normally been estimated also. And again, this estimation normally will be done under the generalized least square. All right, not a OLS. No worries, EV will do it for us. Right, so choosing between both, we have large T, small n likely to be little different because FE is preferable and easy to compute, and so on. So which model will be the best model, right? Normally this is what we need to do, as I told you just now, right? Normally we will start off with the we start off normally to test between whether we want to choose the final model as fixed effect or random effect, right? Or is pool OLS. Here I give you the example behind, and then this is the name of the test: Hausman test and Bruce-Pagan LM test, as mentioned just now. Right here, for example, we want to test between pool and RE, to choose between pool and RE, right? So let's say if like this, this the thing, if the decision rule is rejected, means that this is significant, the chi-square is significant, means that we prefer random effect are more appropriate than the panel OLS. Here we move forward, we like this, we going up like this, right, bottoms up, right? So we choose between these two. From this test, if this is rejected, rejected means that the reject hash null, then we choose this model, and then we choose this model, we compare again with the fixed effect. Okay, compare how we're going to treat between the country specific effect, whether it's a random or whether it's fixed in this sense. All right. So in this sense, also we test whether the rejection of the null favors the fixed effect. If we do not reject, means that random effect is the choice, right? Here in this sense, if it's smaller than the critical value. If it's rejected, means that we will choose fixed effect, right? In this sense. But here again, if we test Bruce-Pagan LM test, if do not reject, we straight away conclude that this is our final model. We do not have to go up here to test with fixed effect. All right. So this is the idea behind the chosen model, the best model. But normally we report all three model, and then after that we choose the best model. We report the three model first, and then we choose the best model, so that we will explain further on the estimation, on the coefficient, and so on. All right, so you can get all this information from this is from Wikipedia, and let me share with you this the book that I told you just now. You can you can have a look of this book actually, Applied Panel Data Analysis Short Panel by Professor Lau Seong Ho from the UPM. This is a good book actually to talk about the idea behind panel data analysis. This book actually include what I discuss here, which is the random fixed effect and the pool OLS and the other model also, right? The other model like GMM, right? The dynamic panel data, which we do not discuss that in this chapter, right? Do not discuss that because that will be the extension. Panel data analysis will be another extension from the time series. It's a totally new things. So is actually can be a subject by itself rather than just for this class. All right. But anyhow, you can get a hold of the book. If you don't have certain parts of it is important, you can refers to his article also, which is a important article. Anyhow, so let me stop by this video, because I think it's already over like 28 minutes right now, which it takes a while. All right, so again, thank you very much for the first part of this panel data analysis video. I will go into the second part, which is the estimation for this one, panel regression, and then we'll move forward into another part, which is non-stationary panel time series. Thank you very much for the attention, and adios.